Today we are going to be filming inside my home office rather than the garage. This is an entirely different genre of video, but we had some questions about the D21 LS swap parts. I've been posting on our Facebook and our Instagram and whatnot. I figured, why not, man? Let's just make a video about the process of designing these mounts, why we're designing them, and all that stuff. Really quick overview here. The D21 that we have that's LS swapped did not have a stock frame. We had to cut too much stuff out because it had the Turbo KA, the small block Chevy, and then the LS. So I cannot use our current D21 for references in regards to the stock frame mounts that the D21 pickups have. Now, we make the LS swap kit for the Mazda B series, and after doing that, I really wanted to come back to the D21 and do right by that as well. I've got a preliminary design here for an LS swap bolt-in engine mount pair to go into the D21 pickups. So it'll be entirely bolt-in. It'll let the engine sit pretty much the same height as our current swap. That'll be using a 302-3 pan. But I figured it'd be cool to walk you guys through the process of how I do this when I don't have a vehicle in the garage that I can actually use for this. Step one, before we even get to anything on the computer here, is I got to reach out to a bunch of people and see if someone can download Polycam, scan their engine bay, and then send me that file. And I had a couple people do that for me, and then basically I go out to our truck, pick an object, measure the distance of that object, take the model that I received, put it into my modeling system, check the scale, basically work the scale out as close as I can. Obviously nothing's going to be perfect, but then I may pick, I pick like random things like the freaking brake reservoir cap to scale stuff out. Either way, I take those models, layer them on top of each other, so I'm basically trying to capture as much information at one time that's relevant to the design of the engine mounts, and overlay it so that I can see any like discrepancies or any differences, because you don't have anything that you can go out and measure with a tape measure. Everything is virtual at this point. That's kind of the first step in getting to designing anything for a vehicle. The model allows me to sort of move around, and I'm going to open it up and I'll show you guys what I'm talking about as far as what these scans look like and then how we manipulate them to get the sketches that we need to start modeling the parts. First things first, we've got a 3D scan in the model space, and you can see our first scan came from a field. I actually like this one because it lets us see the whole engine bay, a rough approximation. I mean, it's pretty close as far as measurements go, but we even have some into the trans tunnel here. We got some texture, so we can sort of tell where the trans tunnel starts to curve back and go towards the center of the truck. And there's also like other junk that shows up in this that's kind of helpful, so we can see how limited our space is, where the fender wells are and everything. The second scan, we actually focused really hard on the mounting pads themselves, because the first scan it picked up some detail, but you can see there's a little bit of variation and stuff. It's a little choppy. Now the second scan, which is this more gray tone, you can see we got a lot better idea of where the holes are on those stock mounting pads. Mazda pads, they were all centered up, which was really helpful, but on the D21 they're actually offset, so I'll try to give you guys a shot here of that. Let's see if we can sort of look top down on the truck, and yeah, you can see there's an offset here for the engine mounts. Now, not only are they offset, the frame is also kind of coming up and moving back down, especially on the passenger side. So take a look at that really quick. So see how the frame comes up, travels along this, like the engine mount is sort of bent at two different axes, but it's flat enough. And let me tell you, when we cut this thing out, it was not very easy to cut out of our truck. So either way, very stout, bent at two different angles, creates sort of odd geometry over here, and then back on this side it's a little bit more basic, but still you can see it's sort of dealing with the frame coming up and back down, and it has sort of this like oblique shape to it. Makes it a little bit challenging to get the right angle here. So you'll notice on these two frame sections that the pad, the mounting plate for the engine mounts, is offset in the D21 pickup. Now in the Mazda, everything is symmetrical. The D21, everything is actually offset about 2 inches. including the trans tunnel. Now, our truck currently is running with a setup that is 2-inch offset in the trans tunnel. I don't think it's worth the time or the effort to cut up your trans tunnel to try to center your engine if you can make it fit in this manner, which we know we can. Looking at this scan, we get it in, we get it scaled, things measure out the way we want them to be. The next step is to get an engine in there. If I can do something that's not a scan, it gives me more accurate dimensions. Scans, obviously, they're just a homologation of pictures. There's going to be some issues in there. So what I did is I looked up an LS3 on a free CAD share site. It's a 3 model share site where you can go ahead and download stuff. And someone had a project in there. I think they were working on some kit car, and they uploaded an LS3 model. So what we do is we take that LS3 model, we go ahead and place it in here with our engine bay scans, and there we go. Now, one of the things I did is I took some measurements out on our truck, and I measured from the pinch weld down to the top of the intake manifold to know where the top of the intake manifold is. I also did that to the heads as well. So I have this matched to the current gap that we have between the passenger side head and the firewall, as well as a height dimension from the pinch weld down to the head. I did that to sort of get the fixed angle that we currently have the engine at and sort of rock it back and forth from there. Looking at this, right, you can see we've got pretty decent layout in here. Now, one of the challenges with this is that the motor is obviously offset, which puts it tighter to the passenger side of the truck, so we want to make sure there's access there, as well as the driver's side. We want to make sure that we get it basically clearing the tunnel over here, clearing the steering shaft and all that stuff. It helps that I have a truck outside that I can take dimensions off of. I know it is going to work in this manner. The main concern was anything going to be in the way of these engine mounts, and currently with this setup, that's not the case. Now, I also added in a CTSV oil pan on this model. It wasn't really necessary because, like I said earlier, I fixed the height of the engine from the measurements that I had out there, knowing that that clears specifically the steering rod. So the next step is I take the original full scan model, now that we know we have the engine centered in the bay like we want, and I go ahead and suppress this model. So I have just the motor mount scan. And when we're looking at the motor mount scan, that gives us a little bit more visibility coming in along the engine. So when it comes to designing the physical mounts, the first thing I want to touch base on is that in this current setup, because we have offset mounts and they're coming in at 2 different locations on the engine, one of the biggest values to me with this was that we had a sort of offset symmetrical mount, and that means the center line of the mounts are all the same, so that I can essentially build one motor plate, one mount that gets bolted to the motor, and one mount that gets bolted to the truck, and then they just get flipped. The direction of them gets flipped, which would allow us to mount them on both sides of the engine. Therefore, production-wise, we can make it much easier, and we don't have 4 different pieces that have to be made per engine mount set. Because the engine mount is going to be offset, you can see here we have our 3 rows of bolt holes on the LS block. Currently, that center row is directly in line with the engine mount, almost maybe like an inch offset from center on the driver's side. Now if we spin this around and we go look at the passenger side, you see there's our motor mount, and you can see our center bolt row here on the block is about an inch the other direction off center. So the cool part with this is I'm seeing some symmetry, even though it's not identical, they're off an equal amount. Here is our motor mount that bolts directly to the LS engine. This is pretty simple, right? Like these things, you have a certain distance, hold a hole, but we slot it out so there's some room to move things around. And really, like in general, you want to have some clearance. You don't want everything to be exactly the same diameter, or the slot to really have like no movement in it. So slot's a little bit long, the bolt holes are a little bit bigger. The actual mounting like of your engine and transmission, realistically the transmission mount is what decides the length setting front and back in the motor, because you're going to have a drive shaft that's going to be moving in and out and all that stuff. So you can control that back end of the transmission, which then means you get a little bit of flexibility with the motor, right? So up here, we've got our 4 slots, and then we went ahead and just 2 simple tabs that we can put in. Now this is all going to get cut on a CNC plasma table, and TJ's going to be putting these together for us. He just doesn't know it yet. He's already doing it with the B-Series mounts, so it's going to be the same thing here. Now, what I've done is this plate, look at the back side, gets cut out on the plasma table, and it gets notched out here for our tabs that go in. That way the weld could be on the back side here, and essentially TJ can work this whole thing in. And if you'll notice, there's a little bit of variation here between this location. As you see that orange line that's running along the back here, that orange line is where the actual holes are. So you can just take that plate and just set it in through this slot. It'll sit right down there for him, be in the exact location it needs to be. Then you can weld that in. Now the next part is the 2 tabs that go up to our bushing, essentially. Now these are used a ton. You'll see them in a ton of LS swaps. It's super basic, super simple. People use them for suspension as well. But we've essentially moved our plates in here a little bit so we can grab some weld around the bottom side of that and get these in. Everything's being made out of 1/4 inch so far, so it'll be fairly stout. I thought about maybe using some 1/8 inch material, but I think we'll just stick with 1/4. That way we only have to buy like one type of plate. But so this is it. This is the motor mount plate that goes on the LS engine. And the key factor here is it's really basic. It's pretty simple to manufacture and fabricate for TJ. Welding should be pretty straightforward. But you'll notice that we've got it offset because the engine mounts themselves on the truck are going to be offset. So we decided to make the offset happen on the engine plate because we can take this plate, right, and we can install it backwards. It's symmetrical. So the center line of this bolt hole is the center line, like the midpoint of the plate, which means I can put it on one side of the motor like this, and I can put it on one side of the motor like that. Gives me 2 different variations, but gives me that symmetrical offset that the stock mount plates, or that the stock frame has. Here it is, right, sitting in that location on the driver's side. You can see it's going to be the back 2 rows of bolt holes, and then on the other side here, we have it mounted but flipped on the other side of the engine. So once again, we've got essentially the same plate just getting mounted upside down, which centers up. You can see it immediately. Centers up the bushing right in the center of the frame mounting location there. And then over here, it's a little harder to see because we got a tighter space, but it's centered on that one as well. So the next part is getting that bushing to mount to something on the frame. We need some sort of piece that goes in between the frame mounting pad and the engine mounting plate. And it's a little bit tougher, right? Because with the Mazda mounts, they drop in directly on the rubber, like the rubber engine mount itself. It's a vertical connection, and you're just tightening it down. Now on this one, when you have a bolt hole like that, it almost removes one of the axes that you can control. And it gets locked in by how it mounts on the mounting pad. So I'm going to go ahead and hide the engine here really quick and talk about how this part was kind of like a major impact for me. But this was a major thing that I wanted to be able to hit, which was manufacturing, once again, one part to use on both sides, and then also to be able to be installed and bolted in like it was a stock engine mount. So stock D21 pickup, like Nissan mounts, you can almost see the color of it, like the shape of it in this engine mount on the model. They have 2 big holes and 2 little holes on them. And those 2 big holes and 2 little holes, what I've done is I've created a plate that has a slot in it. The slot is the size of the bigger hole, essentially, so that we have a little bit of indexability. So the motor can lean forward and back depending on the final placement. Once again, just adding a layer of flexibility so that these don't go out there and then they don't fit. instead of using holes in each location where you get locked in, and then you potentially get some binding because the plate isn't exactly square with the angle that the engine is sitting at. I know that's kind of confusing, and honestly it's kind of hard for me to explain it, but when you're at a 45-degree angle like this and then you lean back, it creates kind of a compounding angle that you have to account for, where eventually it will bind and then it won't really work. I'm going to go ahead and show you guys the mount that we came up with for the base that goes between the engine mount and the stock mounting pad. Here it is. This is our plate that's going to go on the stock mounting pad. Now this thing, it's a little weird here. I do have to fix this spot here. I left a little bit of clearance, but same idea, right? 2 tabs, 1/4-inch steel, and with a back cut so that we can weld them in, and then they're supposed to be longer than the hole so that they can set in no problem. I do have to fix that. I've got a little gap going on there. And then you can see those 2 slots that we talked about. Once again, they're in line and they're going to work that way. So let's go back to the assembly. So there we go. So you can see these 2 working together. So we have our driver's side pair and our passenger side pair. And when looking at them, if I'm going to go top down here, you're going to immediately see, right, like those 2 bolt holes for the driver's side and then the 2 bolt holes for the passenger side. So everything's lined up. You can see we got a good distance here. And this is one important dimension, is this center line length from the bushing here back down to the flat of that engine mounting pad. And that is a critical dimension, because if that doesn't work, essentially the whole thing binds up. It doesn't really creates almost like, I don't even know how to make the shape. It creates a shape that is sort of like a fixed dimension. Either way, we've got that all set up. Go back over here to the passenger side. So again, you can see that's sitting at the perfect height for us. It's nice and flat the whole way back. So this now gives us the ability to run a 1/2-inch bolt through these 2. They're bolted to the engine, but they're offset, right? So that's kind of like a key part here. They're back 1 row and forward 1 row as far as mounting to the engine itself. Now we're making 2 parts, and we're putting 2 of those into each kit so that you can mount an engine to a D21 pickup stock frame, right? Like no changes, just stock frame. It'll bolt right in, almost like you were putting in a stock engine mount. This was kind of daunting to me. Ever since we did the LS swap, I wanted to come back to this and make a proper bolt-in set. I'm nerdy about this stuff. I don't know. I like making things like utilitarian and just work with what's already there, instead of like just saying, oh, just fabricate something, right? Just cut it out and make your own thing. I think it's cool if you can make this as least intrusive into the truck, which is the same thing that I try to do with the B series, right? The least intrusive design that will work with the stock frame, stock truck, all that. I designed this one with a 4L60 fitting in there. The main part of that is the bell housing. Just like the B series, you might run into a condition where you have to work some of the corners a little bit more round with a mallet. Not a huge deal. Does not take an extreme amount of brute force to make it work. You don't need to cut anything. The idea here is that we're also going to do a transmission cross member, as well as cross member at the front, similar to the skid plate integrated cross member that we did on the B series. Essentially just creating the Nissan D21 version of the kit that we made for the B series, and just kind of modifying it from there just to fit the application. But yeah, that's really all I can think of on this one. I mean, there's not a whole lot of crazy stuff that goes into this. But yeah, really a lot of it is just making sure that we can keep manufacturing costs low, we can make the part consistent, and then that the engine itself is clearance. Like clearance in this, when you say you have a bolt-in kit, there's a really big emphasis on making sure that it's clearance through different things. I want to basically get a list. If you guys want to let me know what transmissions you want to run, especially if you have them in-house, we can go ahead and check using Polycam, right? I'm not affiliated with Polycam at all, but you get a free scan. If we take your phone, download the Polycam app, you can scan a transmission or anything like that. We get a couple dimensions, and I can go ahead and check this inside the model. I know some guys talked about a K24 engine mount set. I'm totally up for it. If you got a K24 sitting in your garage and you want to see it in a D21, get your phone out, open up Polycam, get a scan over to me at theoegarage@gmail.com, and we can start looking at stuff, because this is pretty fun to me. I gotta be completely honest, this is like the nerdy side of me that started the car channel in the first place. Like when we started OE Garage, this was the stuff that I like doing in general. We'll see what we can make happen in this, but hopefully, right, We are currently lined up to get a Parks D21 pickup shortly, and I can actually get started on fabricating these parts based on the dimensions that I already have here, and we can get them installed on this parts truck and get a engine lowered in there in LS and just make sure everything fits up the way we thought it would, make any tweaks that we need to make from there, and then we can enter production on this. And we'll probably do it the same way we did with the Mazda, where I step through the production process. So we might start with just engine mounts and then move into the transmission cross member and the skid plate, just to make sure that we can, you know, deal with any fit up issues when we go through the design process. So, but yeah, guys, like I said, this is totally left field for me. I do not make videos like this. If you enjoyed this thing, man, leave a like. If you want to see more of this stuff, let me know. Like I said, I have never done this before. I completely ad-libbed the whole thing. I have no idea what I was doing. It's just kind of, I just downloaded an app so I could even screen record to get you this. Yeah, let me know what you guys thought about this. If you have any other questions, feel free to leave them in the comments, and I'll try to get to them. But otherwise, guys, thanks for watching. Keep your eyes peeled for those D21 engine mounts coming out soon.